Hello, myself Nirja Sartaye. I am from TYB Tech IT and today I am going to explain K-prototype algorithm in ML. K-prototype clustering is an extension of the K-means algorithm that is specifically designed to handle datasets with mixed numeric and categorical features. It combines the features of K-means and K-modes, making it well suitable for clustering datasets into continuous and categorical features. This is the workflow of the algorithm. So starting with the raw data, then selecting relevant features and then pre-processing and then transforming into the analysis ready format. Then applying K-prototype algorithm. This algorithm groups similar data points into clusters by minimizing a cost function that combines Euclidean distance for numeric attributes and the categorical features and the result interpretation. This is the mathematical formula for the K-prototype algorithm. So this is the general formula for measure of dissimilarity. So this is where X is the data points and Z is the cluster point. In this formula, the measure of similarity for categorical variables is given. This is the derivation. And putting it all together, so total dissimilarity for a mixed type of data set, it's calculated numerical distance plus weighted categorical features. This is the implementation of the K-prototype algorithm. So we are importing essential Python libraries, that is NumPy for numerical operations, Pandas for handling data sets in data frame format, Matplotlib and Seaborn for visualization and plotting graphs. In column 2, we have loaded the data set and df.drop. In that, we are dropping unnecessary column which is not relevant. So we have uploaded the we have implemented the algorithm, and in this step we convert the gender column into category data type using as type category. This helps the K-prototype algorithm recognize which columns are categorical so that it can handle them using the K-modes part of the algorithm. Numerical columns will automatically be handled by the K-means part. In the context of clustering, particularly with the K-prototypes and K-modes algorithm, the Huang and Cao initialization methods are techniques used to set the initial positions of the centroids. The Huang method initializes centroids based on the frequencies of the categorical attributes. The first centroid is randomly selected from the data points for the subsequent centroids. The method chooses data points that differ from the already chosen centroids by at least a specified threshold in terms of their attribute frequencies. The idea is to select diverse centroids that represent different patterns in categorical data. This method can be particularly useful when categorical features have many possible categories and you want to ensure the diverse starting point. Cao initialization. The Cao method is more sophisticated and aims to select initial centroids that are well separated from each other. It does so by considering the overall distribution of the data. It calculates a density measure for each point that takes into account both number of points that are close to it in terms of the defined distance and the categorical attributes. Points with higher density measures are more likely to be selected as initial centroids. This method tries to find centroids that are representative of data's density structure. Both methods are designed to improve the convergence of the K-modes and K-prototypes algorithms by providing a good starting point that reflects an underlying distribution of the data. This is the implementation. K-prototype cost is computed as the sum of dissimilarities between each point in the dataset and the centroid of the cluster it belongs to. The dissimilarity measure used in K-prototypes combines the cost of numerical features typically calculated using distance metric like Euclidean distance with the cost of categorical features, which is calculated using a matching dissimilarity measures. For example, the simple matching dissimilarity where the cost increases when the categories do not match. Here's what cost represents. For numerical attributes, the cost is the sum of squared distances between the data points and the centroids of their respective clusters. For categorical attributes, the cost is typically the numerical distance between the data points and the modes for the categorical respective clusters. This is the implementation of the cost. So concluding, the K-prototype is the clustering algorithm which is the combination of K-means and K-mode developed by Huang. For the implementation of its algorithm, the researcher needs to filter the columns carefully, especially for the categorical variables. The categorical variables must be relevant to the analysis and are not meaningless information. Besides that, the quality of the input data affects the clustering result, that is cluster initialization, and how the algorithm processes the data to get the converged result. Thank you. This slide is represented by Nirja Sartaya, Sharvari Shalgar and Preetam Rangari.